Welcome back to the deep dive. So, if you're building anything serious with large language models these days, you know the feeling, right? This constant contradiction. You're shelling out, paying a premium for speed, but then wham, you hit these like crippling usage limits
Hmm.
where you invest big for the absolute top tier power, and then you just watch those OpEx costs creep up month after month. It's tough.
Yeah, that tension point is real. That whole trade-off between, speed, power, and just the sheer cost. And that's exactly the spot Anthropic seems to be targeting with their latest model. They've clearly been listening to, well, the complaints, the frustrations from users. So today we're diving into Claude Haiku 4.5. It's a model that promises, basically, to keep most of the useful smarts of their other models, like Sonnet, but with a really focused mission, just slash latency and cost, aggressively.
Okay, that is a huge promise. Aggressively slashing costs and latency. But look, we're not here for the marketing fluff. Our mission today, yours and mine, is to cut through all that launch noise. We need to figure out where this model, Haiku 4.5, actually fits into your stack.
Yeah.
We need the real numbers, the architectural patterns, so you can actually ship work, right? Instead of just reading another blog post about a new model.
Exactly. And Haiku 4.5, it's important to say, isn't trying to replace the big guns, the flagship models. It's designed to fill a very specific gap. Think of it as the new, small, fast sibling in the 4.5 family. It's really engineered for those high-volume jobs, where the main constraints aren't like ultimate genius-level intelligence, but response time. And crucially, dollars per request. We're talking things like high-traffic customer support agents, real-time assistance, maybe translation, and it's interesting, coding sub-agents, lots of them running in parallel. It's built to scale, but cheaply.
Okay, let's unpack that a bit. One of the core ideas you mentioned, this hybrid reasoning, that sounds key to how Haiku 4.5 works. Can you walk us through what that actually means? And maybe more importantly, how does it affect the speed? Does it slow things down?
Right, hybrid reasoning, it's essentially like having two gears. In its default mode, the model is all about speed and low cost. It's tuned to give you that quick, reliable answer almost instantly. That's how you get that super low latency everyone wants. But the hybrid part that comes from this optional toggle, they call it extended thinking.
Ah, extended thinking. Okay, that sounds like where the catch is, like where the cost gets hidden, maybe?
Actually, it's kind of the opposite of hiding it. They make the cost explicit. It's optional. So when you flip that switch, you're telling the model, okay, this specific request, it's trickier, it needs more thought. And then the model spends more internal cycles, planning, doing that chain of thought thing, checking its work before it gives you the answer.
Okay, so you only pay for the heavy lifting when the task actually needs it. That makes a lot of sense for managing compute spend. But let's push on that trade-off. How much slower are we talking when you hit that toggle? Doesn't that kind of kill the whole speed advantage Haiku is supposed to have?
That's the balancing act, right? The engineering challenge they had to solve. Think of it like asking a person a question. Haiku in default mode. That's like asking for a quick fact and FAQ answer. It's instant, usually right, maybe 95% of the time. Enabling extended thinking. That's like asking the same person to, I don't know, draft a complex legal argument. They need way more time to think, to plan. So yeah, there's added latency, but it's worth it for that complexity. And because you'd probably only use it for, say, 5% of your really tough cases, the overall system latency stays low. You're basically setting a thinking budget for each request.
Right, right. So this tiered setup, Haiku for the day-to-day stuff, Sonnet for the really complex problems, it feels like Anthropic is aiming to cover the whole development lifecycle, not just the absolute cutting edge.
Absolutely. Sonnet 4.5, that's still your go-to for the really complex, novel reasoning tasks, no question. But Haiku 4.5, it's targeting what they call near-frontier competence. Basically, good enough, really solid performance for the bread-and-butter jobs, the reliable stuff. And the benefit for teams is huge. If you can standardize on one provider, one API stack, you can just shift workloads up or down the complexity ladder. Haiku, Sonnet, maybe Opus, without ripping everything out and starting over with a different provider. That efficiency, that's a big deal. It's kind of a strategic lock-in, too.
Okay, we've talked architecture, the promise. But promises are cheap. Let's see the receipts, the benchmarks. Where does Haiku 4.5 actually surprise? Especially, you mentioned coding. What about developer tasks?
Yeah, the performance numbers are where the rubber meets the road for Haiku's utility. Benchmarks, they keep everyone honest, right? Especially for real developer work, fixing bugs, generating code.
So give us the headline number. What stands out?
The big one, the headliner, has to be its score on SWE-bench verified. That's kind of the gold standard for testing end-to-end bug fixing in actual Kun repositories. Claude Haiku 4.5 scores a, frankly, remarkable 73.3%.
73.3% on independent bug fixing.
Wow. Okay, that's not just a number on a chart. That feels like direct economic value. How does that translate? Like practically, how much engineering time could that actually save a team using autonomous agents for that kind of stuff?
It saves real time. The source material makes a point of saying this score puts Haiku right up there, next to much larger, much more expensive models. Think about it. A 73% success rate means for nearly 3 out of 4 common bugs it encounters, your automated agent, powered by Haiku, is spitting out a valid patch that passes the tests. That lets your human engineers shift their focus from chasing down those routine bugs to, higher value architecture work or feature development.
And that coding ability, it seems to carry over into other agent-like tasks, like actually using a command line. Exactly. On Terminal Bench, which tests that sort of thing, it got 41.0%. And on OSWorld, which simulates more general computer use, 50.7%. But honestly, I think the really interesting signal for developers might actually come from the academic tests. They show it has pretty robust reasoning ability underneath.
Okay, let's clarify those, because the names can sound a bit like jargon. We see scores for AIM and GPQA Diamond. Why should a developer care if a model is good at, like, high school math contests or grad-level questions?
That's a fair question. A is a high school math competition, right? Haiku gets 96.3% when it can use Python tools. That's huge. It shows really good tool use and, crucially, reliable mathematical accuracy. That's fundamental for anything involving data processing, finance apps, you name it. And maybe even more telling is the 73.0% on GPQA Diamond.
GPQA Diamond, remind us.
GPQA Diamond tests complex reasoning across multiple domains. Think graduate-level knowledge biology, physics, CS, stuff like that. Nailing 73% there shows it's got depth beyond just predicting the next line of code. It can synthesize info from different areas, apply complex logic reliably. That kind of deeper reasoning is what lets it handle, say, the nuances in a complex code refactoring request, not just simple completions.
Got it. And one final really important point on methodology. These scores weren't, like, juiced in a lab somewhere with tricks.
Correct. And the sources really emphasize this. Haiku's results came from standard setups, fixed thinking budgets like we discussed, and crucially, no test time compute tricks. That's vital. It means the 73.3% you see on the benchmark, that should be repeatable. You should be able to get that or close to it in your actual production environment. Reliability at scale, that's what makes a model truly useful, not just a high score on a leaderboard.
Okay, so performance looks surprisingly solid, especially for the price point. Let's talk about that price. This feels like where Haiku 4.5 could really become a go-to tool, especially in, cost-conscious stacks. High performance is great, but if the bill makes your eyes water?
Absolutely. For teams really watching the bottom line, measuring success by cost efficiency, the pricing is probably the defining feature here.
Okay, lay it out. What are the key numbers people need to remember?
It's pretty straightforward. The API pricing is set at $1 per million input tokens and $5 per million output tokens.
$1 input, $5 output per million tokens. Wow. That is aggressive.
Yeah.
How did that stack up against, say, Sonnet or Opus? That context is key.
It creates a massive gap. Just look at Sonnet 4.5, that's $3 input, $15 output. And the big one, Opus 4.1, is $15 input and a whopping $75 output. The savings are immediate, potentially huge. The sources basically say the punchline is clear. If you take a moderately busy chatbot or maybe a fleet of those sub-agents we talked about and port them from Sonnet over to Haiku 4.5, you could easily see your monthly bill drop by 3 times. Maybe more. And your throughput could actually go up because it's faster.
A 3x cost reduction. That's not pocket change. Okay, but where's the catch? Is there a hidden cost? Are we talking like a 10% jump in error rates maybe? Is the quality drop only acceptable for really low-stakes stuff, or does it genuinely hold up for typical, say, back-office automation?
That's the right skeptical question to ask. And the reason the quality seems to hold up, based on the reports, is because you're smart about where you deploy Haiku. You aim it at those bread and butter tasks we mentioned earlier. The ones where the input is fairly clean, the context isn't insanely complex, and the output you need is pretty well structured. For those common jobs, the model is apparently so well optimized and aligned that the slight difference in raw intellect compared to Sonnet just doesn't really show up as more errors. So yeah, the 3x savings seems real as long as you don't ask Haiku to, solve cold fusion for you.
Fair enough. Use the right tool for the job. And Anthropic is apparently also offering some tools to trim costs even more, specifically something called prompt caching. That sounds technical, but potentially huge.
It is. It's arguably one of the most important architectural tricks for managing costs with these models. Prompt caching. It lets you store the static parts of your prompt, like your big system instruction block, or maybe a large chunk of context that doesn't change often. You pay the full input rate just once to write it to the cache, but after that, every single time you make a call that uses that same cache block, you only pay this tiny, tiny read rate. For Haiku, it's just $0.10 per million tokens read from the cache.
Wait, 10 cents per million tokens. Okay, run the math for me. If my standard system prompt the agent persona rules whatever is maybe 10,000 tokens long, before I paid, what, a fraction of that $1 input cost every single time I made a call?
Exactly. You paid for those 10K tokens every time. Now you pay the input cost for 10K tokens once to cache it. And then for the next million requests, you pay almost nothing for that chunk. Maybe a penny in total for the prompt reads over 1 million calls. It fundamentally changes the cost equation for repetitive tasks, that overhead cost. It basically goes from linear to near zero. This is massive for things like guardrails, format checking, high-volume agents where the setup instructions are always the same.
And tying it all together, this combo of low base price and caching must really help with the biggest headache for heavy users: hitting those API usage caps.
Precisely. Fewer tokens needed for some tasks because it's efficient, much lower cost per token anyway. It all means you can just process way more requests, way more events before you hit either a hard rate limit or just your own budget ceiling. The advice for Pro and Max tier users seems pretty clear. Shift all your routine, high-volume, predictable work over to Haiku 4.5. That saves your precious Sonnet or Opus capacity for the truly gnarly problems, the high-stakes steps that actually need that top-tier reasoning power.
Okay, performance is solid. Price is definitely right. Now, let's get practical. We need the decision framework, the architecture blueprint. Give us the quick mental model. If you're listening to this, when should Haiku be your default choice? And when do you absolutely need to stick with Sonnet?
Right, the cheat sheet. Haiku 4.5 should probably be your default when throughput is king, when speed and volume matter most. So think customer service chat, definitely. Support ticket triage, maybe initial summarization, running translation jobs, and especially, like we said, when you're running agents in parallel. If you have one main planner model, maybe Sonnet, breaking down a task, and it calls 10 worker agents to do the subtasks, those 10 workers should almost certainly be Haiku 4.5. Fast and cheap execution.
Right. And also for the less glamorous but essential stuff. The plumbing of software development, guardrails, glue code, like translating data formats, making sure things fit a strict JSON schema, auditing logs, and just everyday coding, generating unit tests, small refactors.
Exactly, all that stuff. Sonnet 4.5, on the other hand, that's your specialist, your expert consultant. You save it for when that complex multi-step reasoning is absolutely critical, non-negotiable. Think complex scientific analysis, maybe strategic planning that needs to weigh conflicting information, or when you're dealing with really long, dense context like analyzing a huge research paper or untangling a messy ancient code base. And maybe the problem is what you'd call fragile, meaning one small mistake early on, one bad assumption, and the whole thing collapses. For that, you probably want the extra safety net of Sonnet's deeper reasoning.
Okay, that planner worker model makes a ton of sense for throughput, but let's talk reliability. What about data guarantees? Using a smaller, faster model like Haiku, how important are things like typed contracts, strict schemas, in making it reliable at scale?
Oh, they're critical. It's not just about swapping the model name in your API call. You need to think about the architecture around it, defining strict JSON schemas for your inputs and outputs that massively reduces ambiguity. You're basically constraining the model's creative writing tendencies. And smaller models like Haiku tend to excel when ambiguity is lower. They're really good at following strict instructions. So by enforcing those typed contracts, you turn Haiku from just a fast text generator into a reliable component, a predictable machine spitting out the data shapes you expect every time. That makes your whole system much more robust.
Makes sense. And we absolutely have to touch on safety, especially if teams are going to use these fast sheet models for public-facing stuff, maybe agentic systems. The notes say it shifts under AI Safety Level 2, ASL2. What does that actually mean for a team lead thinking about deployment?
Yeah, ASL2, that's Anthropic's internal safety classification. Practically speaking, it means the model has gone through a battery of rigorous testing for alignment and safety. It's been cleared for use in high-scale, potentially public-facing applications, It confirms it has strong defenses against generating harmful content on simple requests, and importantly, it's robust against common prompt injection attacks, people trying to trick it into ignoring its safety rules. Having a model that's fast, cheap, and demonstrably careful, that kind of changes the default assumption for production systems. It gives teams more confidence to actually deploy these scalable agents without constantly worrying that a routine task might suddenly go off the rails or leak sensitive instructions. Hashtag hag outro.
This has been super insightful, a really detailed look. Okay, let's try and wrap this up with the core verdict. Let's answer the 3 big questions every developer probably has about Claude Haiku 4.5. First off, is it good?
Yes, definitely. It's strong, it's steady, it's fast, and it holds its own surprisingly well, especially in those key areas like coding and basic agent tasks. It's way more than just a cheap alternative. It's genuinely capable.
Okay, second question. Is it cheap?
Unequivocally, yes. It's the cheapest Claude model that you'd realistically want to put into a serious production environment right now. And that cost gap between it and Sonnet is huge. The math just works immediately for anything high volume.
And third, the big one for heavy users. Does it actually help with those painful usage limits?
Yes, absolutely. In practice, it does. Lower cost per token means your budget stretches further, and often fewer tokens needed per task means you hit rate limits later. You can just get significantly more work done within the same API usage constraints, and that frees up your premium model allocation, your Sonnet or Opus calls for the problems that really truly need them.
Yeah, this whole release, it feels less like just another model drop, another point on a leaderboard.
Yeah.
It feels more like a workflow moment. It kind of forces you to rethink how you structure complex tasks.
Precisely. And that's really the challenge we want to leave you, the listener, with. Don't just read the blog post or listen to us talk about it. Take one of your existing production workflows this week. Just one. Try splitting it. Identify a planning phase, maybe keep Sonnet for that, and then an execution phase. Swap in Claude Haiku 4.5 for those execution workers, and then track the real results. Look at your latency, your costs, your error rates week over week. Because the goal here isn't just chasing some abstract benchmark score. It's about shipping features faster, more reliably, with costs you can actually predict and manage. That's the real test for a model like Haiku.